All right, some announcement first. So yesterday I posted for lab number 2, which you will be graded next week. So I already made tutorial videos for you this time earlier, so you can start planning your time to watch them. So this time the topics will be about loops, for loop and while loop. It's going to be the exciting part for the course. We're going to get to write more and more powerful programs using loops. And also, there is a very powerful technique called debugger. I believe most of you didn't know about this technique, but just learned it from a tutorial video. I try to be very thorough on the video to show you how it works. And for your quiz number 2, it will also be next week. I'll give you the preparation guide early, maybe hopefully early tomorrow to tell you exactly what to study. And it'll be the next week. Okay? Now, let's go back to our business for if statements. Hopefully I can finish most of them today. There might be a little bit I need to cover on Wednesday, but on Wednesday we definitely start with the loops. And then before the reading week, we'll all talk about loops. After the reading week, we talk about objects, which will be another important part for this course. All right. Now, the reason, the slides are slightly cut off. I'll just read the title to you. So we're going to learn about so-called logical laws for the logical operators. So far we learned about negation, we learned about conjunction, and we learned about disjunction. So these are the 3 operators we have learned so far. The reason that I want to show you some basic logical laws, the reason is, whenever you're trying to analyze the behavior of your program, especially you got if and else or else if structure, it is really important to see what does it really mean when you go to a particular branching condition. What does it really imply from there? So that's why we are trying to study the logical law, the basic ones, not really complicated ones. They're rather intuitive. And then I'll show you examples as usual. Okay, now, the first one is really easy. It's about the negation. Okay, I'll just read it to you. So what does it really mean? When you have some relational expressions, so what does it really mean when you take a negation of the relational expression? I'll give you an example over here right away. Okay, so now the table over here is what you have in the slides. Okay, so let's just go over the table. It's very easy to follow. Okay, so for example, let's say if I'm given a relation which is I is strictly larger than j. So what does it really mean when I try to apply the negation to it? What does it really mean? So it is not the case that I is strictly larger than j. It will be equivalent to saying I is simply less than or equal to j. Okay, so the key is when you have strictly larger than and you're trying to apply the negation, it will turn out to be just less than or equal to. Similarly, let's say here you got I less than j over here, and you're trying to apply the negation to it. What you will have is larger than or equal to. Okay, so these are the kind of rules you have to know, but you pretty much know them already before this course. Okay, so that's a table you can go through, very intuitive. Let's just see example how you can apply that. I kind of show you 2 fragments of code over here, left and right. The left and right basically is trying to use the same branching condition over here. Although from the syntax point of view, you don't really see them explicitly. But let's see why they're equivalents. So what I'm claiming is these 2 programs, the left and the right, they are simply just equivalents, which means they'll behave exactly the same at the runtime. But let's see why. Okay? It's very easy to see the correspondence over here. First of all, I want you to look at what's the structure of the 2 programs. You got if and you got else. And the right-hand side, you also have if and else. When do we reach the else part? It is when the if part simply evaluates to false. So if it is not the case that the if branching condition is true, then we go to the else part. We know that pretty well from the previous lecture. So now for the first one, let's have a look. The first condition over here is simply I strictly larger than j. So what does it really mean when we actually reach the else part? That means it is not the case that I is larger than j, right? So that means it is not the case I is larger than j, which is equivalent to I is less than or equal to j, according to the law. Okay, similarly, if you look at the right-hand side program over there, we have the branching condition over here, I is less than or equal to j. So what does it really mean when we reach the else part? It is when the if condition there simply evaluates to false, which means it is not the case that I is less than or equal to j. And according to the table, what do we have? We got I strictly larger than j, right? Okay, so that's kind of the analysis I would expect you to do, maybe in the quizzes or in the exam. Okay. Also, when you actually try to program your if structure, you can feel free to use either flavor. Okay. So now let's run some example to show you that why they are really equivalent. Okay, let me just write it to show you. I got two test cases for you over here. So what you have to pay attention to is the color of the action. Okay. So what I want you to see is, in the first case, we got action 1 in blue. We got action 2 in green. For the right-hand side, we got action 2 in green still and action 1 in blue, right? So let's see how they will be executed. Let's try test case number 1. Test case number 1, let's say I is simply 17 and J is 3. In this case, what do we have? In this case, when you try to evaluate I larger than J, you got 17 larger than 3, which would be true. So in this case, we're going to execute action 1. It's very straightforward for the left-hand side program, right? It's going to execute action 1. What about the right-hand side? If we claim that the behavior of the two sides are equivalent, they should execute action 1 as well. But how? So I over here is 17, and also J over here is 3. 17 less than or equal to 3 is going to give you false. That means you will go into this particular else branch and then execute action 1. So you can see that for this particular input, both cases will execute action 1. So for this case, they are equivalents. Okay? When the relation is actually simply true for the left-hand side over here. Let's try the second case. The second case over here, let's say we try test 2, and then we got -4 versus 13. Okay? It's kind of flipped the relation. So now, when we try to evaluate the left-hand side, what does it really mean? So we got -4 larger than 13, which we know is false. That means we are going to execute else branch action number 2 for the left-hand side, right? What about the right-hand side program in this case? In that case, you got I being -4 and J being 13. So -4 less than or equal to 13 is going to give you true. So that means you are going to execute this particular action 2, right? You can see they are, again, equivalents. Okay? This simple example simply shows you that whenever you got if-else structure, the way you actually organize your branching condition can be rewritten in either way, as long as they are the negation of each other. That's the point for this particular slides. Okay? Of course, the table there is simply enumerate all the law you should really know about, but they should be quite intuitive to you, right? So negation law is very simple to follow. Okay? Any question about the negation law here? Okay, we okay? Yeah, you can just go over the example again when you review. So the next one is going to be more interesting to actually learn, which is logical law for conjunction and disjunction. Okay, I will go straight to the points, and you can read the slides. It's really self-contained. Okay, what I will do is I will just try to give you some intuition on the iPad over here. Okay, so now let's think about this. For now, can we just assume you have Boolean, let's say P, which can be either true or false. Also, you have Boolean Q, which can also be true or false, right? That's simply just Boolean type. Now, let's consider the following. We know that P and Q, if we simply write this, as we learned before from the table, okay, sorry, again, it's cut off. We got P and Q. P and Q are both Boolean. So now, let me try to maybe lower that a little bit for you so you can all see that, okay? Okay, there we go, P and Q. We say that the only way to really make P and Q true, this particular conjunction true, is when P is true and Q is true, right? That's what we said before. So now let me ask you the following. What does it really mean when we say it is not the case that P and Q is true? I'm simply adding a negation to the conjunction. So what does it really mean? How can I actually make the conjunction of P and Q not to be true? How many possible ways can I make it happen? Well, we say that the only way to make P and Q true here is when both P is true and Q is true, right? But now how do we make the conjunction false? It's simply either P is false or Q is false, or both, right? So now, let's rewrite that a little bit, which means it's either that P is false, not P, or it is not the case that Q is false. Okay? So this is your first logical law. Okay? I'll simply just say equals equals, which means they're equivalents. So whenever you see, I will show you the application why we're learning this law. Whenever you see some negation over conjunction over here, it simply means either the left-hand side operand is false or the right-hand side operand is false. You don't need to memorize it, just get the intuition over here. Okay? That's for the law of a conjunction. And we're going to see some application in just a moment. Okay? What about we'll see the application right away? Okay? Guys, are we okay with the intuition for this one here? Let me just repeat very quickly in case you get lost. We know that the only way to make conjunction true is when both operands are true. So now, what does it really mean when the conjunction is not true? That simply means either the left operand is false or the right operand is false. So we got or over here. Okay? So it's a very famous rule law called De Morgan. For those of you who might take discrete math later, you will learn about this law. I'll just introduce you in an intuitive way. I'll go through the table a little bit later. It's not that important at this point. Let's see the application right away. Okay, right away. So now we only learned about the law for conjunction. So let's have a look at this. Over here, I want you to look at this particular if-else statements over here. Okay? So now you can see that for the if condition, I simply got a conjunction. And as we learned from the tutorial video, this is how we specify an interval, right? We're saying that I should be in between 0 and 10. It should be both larger than or equal to 0, and it should be less than or equal to 10. Okay? That's good. So now, I want you to help me answer this question over here. So when is action 2 executed? Under what circumstances is action 2 going to be executed? Especially you can see action 2 is in the else branch. So what does that mean? We only execute action 2 when the if branching condition there is false, when its negation is actually true, right? So now, can we try to apply the law a little bit before we see the answer? Let's try, okay? So now, what we want to use, here's a critical thing. We know that you only reach this particular point for the else if this particular if branching condition here is false. It is not the case. Let's try to do a little bit of math over here, very easy math. So we only execute the else branch when it is not the case that 0 less than or equal to I, and also I is less than or equal to 10. Okay, oh, I lost you again. Sorry about that. Thank you. Let me just put it here. How about here? Okay. Okay, so now again, we are only going to execute the else branch when this particular condition for the if is actually false. So that's why I put a negation at the front. Okay, so now, how do we simplify this using the law? How do we do that, right? Again, we know that the only way to make this particular conjunction true is when both of these are actually true. Now we're saying that it is not the case that both are true. So it can be either the left-hand side is false or the right-hand side is false, right? So now how do we simplify that? So what I will do is I'll simply go for, I might go a little bit, what I will do is, let me just simplify together with you on another page. Okay, what we have is, so we have if over here, 0 less than or equal to I, and I less than or equal to, let me be consistent, 10. Okay? That's what we have over here, and then we got else. Okay, so now we're asking, under what circumstances are we going to execute else branch, right? Let's try to simplify that. So what we will get is, for this particular part, we know that this branching condition will just evaluate to false. So we got not the case, 0 less than or equal to I, and I less than or equal to 10. According to what we learned before, how do we do the negation over that? Well, it will simply be, it will be not the case, 0 less than or equal to I, right, the left-hand side. Or it is not the case that the right-hand side is the case. Are we okay with this particular rewriting here? There's a reason we need this kind of analysis, as you will see in the example. So now, can we also apply this negation over here? We can. which is equivalent to, when we got negation over less than or equal to, that means 0 strictly larger than I, right? Or over here, I strictly larger than 10. So this is the final answer we have. So are we okay with this analysis over here? The critical point is, if I ask you about what would be the condition for executing the else branch, all you got to do is take whatever that's for the if branching condition here verbatim, and then simply apply negation over there, right? Okay, and then you just try to simplify that. Okay, that's the idea. Now, so that's for the very first question. Okay, for the first question over there, we can simply get it. So when you see the slides, that's exactly what we have. Okay, just make sure you know how to do it. Now, let's do something interesting over here. Have a look at this particular one over here. Okay, second one. If you look at the if-else branch over here, can you see there's anything logically wrong with this particular if branch over here? Remember, the very idea about having an if-else statement is sometimes I may have to go to the if branch, and sometimes I may have to go to the else branch. If it happens that I will never be able to go to one of the branches, then something wrong, right? Can we find any problem over here for this particular one? There are different ways for you to look at that. If you simply try to look at this, if I say I less than 0 and false, what would that evaluate into? Just false. Agree? That means this particular branch is simply just equivalent to false. And then what does it so in that case, when should we execute the else branch? Negation of false would just be true. That means for the else branch, we will always execute this particular action over here. Okay, that's what happened here. So what's the logical error for this particular if statements? That means it doesn't really matter what you put for action 1. You will never be executed because the else because the branching condition here is always false. So you never get a chance to execute action number 1. However, you'll always execute action number 2, regardless of what the input values are. Okay, that's the problem. Okay, so now you can simply look at that. Okay, so now if you look at that, it's going to be just like that, just false, right, for the if branch. And then if you take the negation of the if branch, it will just be just true. Okay, that's what you have, just true. However, I do want to apply the law just once more to show you, and then everything else for disjunction will be symmetric. Let's do it one more time, okay? If you think about, let me just do another one for you. Okay, so now what I will write down is, I'm just copy this. So it's I less than 0 and false, right? So what we have is if I less than 0 and false over here, and then we do something over here, otherwise we do something else. Okay, let's review again. Let's say I simply don't want to simplify this directly to false. There's another way for me to see it, just applying the law we just saw. So now, what does it really mean? When I go to the else branch, what does it really mean? That means it is not the case that this evaluates to true, right? So now what we have over here is, it is not the case I less than 0 and false. Okay? So now let's try to apply our law for the conjunction, right? So if I say it is not the case that the conjunction is true, that means either the left-hand side is false or the right-hand side is false. It's equivalent to either it is not the case I less than 0 or, remember, changed from and to or it is not the case false. Okay, so now for this part, we can easily simplify that. It would just be I larger than or equal to 0. Or this part here, not false, will just give you true. So now, can we apply any simplification here? Yes, we can. Because remember, for disjunction over here, as long as one of the sides is actually true, it will simply just give you true. So you will get a similar result. Okay, so you got two ways to derive. So later on, if I give you something like this, I will ask you whether there's any logical error for this particular if-else branch. So what you got to analyze is to see if any of the branches will just evaluate to either true or false. That means the other branch didn't get a chance to ever get executed. Okay, that's kind of the idea. Okay, let's go back here. Okay, that's about the second example over here. Okay, exactly what I just said. So now let's try once more. What about this guy here? Third example, right? Over here you can see I got I less than 0 and I larger than 10. Is it ever possible to have such number? No, right? Actually, one of your quizzes question was like this, right? Which expression will simplify to true or false? It's really important for you to see that, okay? So now again, for those of you who are still struggling, let me draw once more for you. You can see we got 0 over here, and we got 10 over here. When you have conjunction, that means you want to have a number such that it's less than 0 and at the same time is larger than 10. There's no such number, okay? So that means this part over here can just be simplified to just false. And that means the else branch over here would be the negation of false, which will be just true. That's again problematic. Okay? So every time you design your if-else conditions, make sure you really always get a chance to sometimes go to one branch and sometimes go to the other, but not really one branch will be simplified to true or false. That's the idea. Okay, and for the answer over here, you will just see exactly what I just mentioned. Okay, it's going to be false, and then the other branch will just be true. Okay, any question about this example over here? So these examples simply show you how you can apply the logical law for the conjunction. Okay, so now for the case of the disjunction, it's going to be similar. So I'm going to go a little bit faster for the disjunction. All we have said will be symmetric. Okay, let me just try that over here. So this is what we just said, right? That's about conjunction. Let's use the same slide over here, but I'm going to say over this. Let's say I still got P and Q over here. I got the two variables over here. So what does it really mean? When I say I got P or Q, and then I'm trying to say it is not the case that P or Q holds. So what does that mean? Think it this way. We say that the only way for P or Q, think it this way. P or Q will be true as long as either this is true or this is true, right? Either way will be okay. However, I'm not telling you the disjunction overall will just be false. What does that mean? That means both the left-hand side and the right-hand side, they're both false. Okay, intuitively, that's how you interpret that. Okay, so that would just be, it is not the case that the left-hand side is true, and also it is not the case that Q is true. Okay, that's the second law. If you really want to have hints about remembering this, this is how you can think about. Every time you got negation over conjunction, you apply the negation to both sides and change from conjunction to disjunction. And every time you have negation over disjunction, do similar application. You will do negation to both sides and then change from disjunction to conjunction. Okay? That's how you remember it, if you want to remember. Now, let's have a look at the example very quickly. So we're going to do basically the same exercise over here. I'll just show you one of them, and the other two I'll leave as an exercise for you. The way you derive the outcome will just be the same. Okay? So now let's do the first one over here. The first one here, again, I'm going to copy to iPad and then show you. So here we got I less than 0 or I larger than 10. So what does that mean? Okay, let me just add a page over here. Okay, what I will do is I will say if I larger than less than 0 or I larger than 10. Okay, just like that. Okay, let's say that's the if branch and we do something over here. Otherwise, we do something else over here. Okay, that's what we have. So now how do we know? The question is, given this, what would be the circumstance under which the else branch will be executed, right? So let's try to apply the rule very quickly for you, okay? So that means if we can execute else branch, that simply means this particular branching condition will evaluate to false. It is not the case. So let's try that. You simply say not the case, and then copy this condition here verbatim. I less than 0 or I larger than 10. That's what you have, right? Let's try to apply the rule. If I say that it is not the case, the disjunction is true. That means both both sides are actually false, both sides. So that means not the case, I less than 0, and it is not the case, I is larger than 10. That's what we have, right? That'll be good enough, but let's just go a little bit further. What does it really mean when I say it is not the case, smaller than, right? I simply can simplify further. I larger than or equal to 0, and I less than or equal to 10. That's what we have. Okay, I simply turn less than into larger than or equal to, and I turn larger than into less than or equal to. Okay, similar idea. Now let's go back to the original example over there. So that's what we just did together over here. Okay, so now let's do the next two examples. I will try to skip. I'll try to go very quickly on them. The way we derive these two examples are just symmetric to how we did it for the previous one. Now let's just have a look at this. For this particular disjunction over here, okay, so over here, what would be this condition be simplified into for this one here? Well, you can see it's a disjunction over here, and we know that one of them is already true. No question, it's simply just true. So that means your particular if branching condition here is always going to be true. That means you never get a chance to go to the else part, never, ever. So that's problematic. Okay, I'll leave that. This one is easy to see. What about the third example over here? The third example, you have to draw a little bit diagram to convince yourself. Let's try that quickly. For this one here, you got I less than 10 or I larger than or equal to 10, right? Would that be either true or false, or it's hard to say? Try this over here, okay? If you try, it's actually quite easy to see. I got 10 over here, the number. I'm saying that it can either be less than 10, or it can be greater than or equal to 10. Basically, it's actually cover all the possible numbers in the number line. So that means this particular condition here can just be simplified to true. Okay? Because we're using disjunction over here. So that's true. So what does that mean? That means the else branch over here would just be the negation of true, which is false. So you never get a chance to execute action 2. Okay? So far we have seen quite a number of examples over here. The lesson is, whenever you're given some branching condition for your if statements, you always want to see, so what does it really mean? When I don't satisfy this particular branching condition, would it be simplified to either true or false? If that's really the case, that means the condition here is not appropriate. The reason that we want to have selection is because sometimes you want to go to one branch and sometimes you want to go to the other. Should not be always go to a particular branch. No. So over here, if you look at this particular example over here, let's say we go back to this particular one, and we agree that this particular condition here will just be simplified to true, right? So that means you'll always execute action 1. You never get a chance to execute action 2, because action 2 is in the else branch. True will always be true, right? So that's why this particular fragment of code is simply problematic. So why would you need an if statement over here if you just want to execute action 1? Why don't you get rid of the if statement, just write action 1, right? That's kind of the idea. Okay, so now after this, I'm going to talk about something also quickly, and then we'll move on to something very interesting called short circuit. But before I get there, one more thing to show you. For those of you who are interested in doing a little bit of math on your own, let me just show you how you can do it quickly. So this table over here is also covered in the slides. So the two laws that we talk about is summarized over here. But now, for those of you who want to be mathematical, how do you prove these two rules mathematically? The easiest way to do it is by using a truth table. Let me show you very quickly. I'll show you what just one row, and then you will see the idea. Again, let's say rather than P and Q, we simply got B1 and B2. Okay, we got B1 and B2, and they got 4 different combinations of true and false. We know that pretty well. So we enumerate all the possibilities. Now, how do we prove that this particular Boolean expression is always equivalent to this particular Boolean expression. That's what we said is a law. But how do we prove it? You simply substitute B1 and B2 over here using the value for that particular row. I'll give you one example. Let's say for this particular one, we got true and true, right? So that means B1 will be true, B2 will be true, B1 will be true, and B2 will be true, right? And they will simply evaluate to the same result, either true or false. As long as they're the same, we're fine. Let's see how it's going to be evaluated. In this case, true and true is going to give us true. And then take the negation is going to give you overall a false. Okay? So that is why you see a false over here. Okay? So what about the right-hand side, the second expression? If you look at the second expression over there, you apply the negation to true first, right? You got a negation here, which means you got false. And then it is not a case, B2, which is also true. So not true is going to give you false. And then you do false or false. Well, that's the only way to make a disjunction false. So overall, it's going to give you false. So if we just prove that for this particular scenario where both are true, it's going to give you the consistent result. If you follow the same exercise, all the rows will give you consistent result. That's how you prove it mathematically. Okay? I wouldn't bother you with the further analysis. Okay, but for those of you who are interested, you can feel free to do it, just to strengthen your understanding. Okay, that's about logical law, and then let's see what else. Okay, so now from now on, we are gradually lifting ourselves from the very basics of Java programming. We're learning about logics, and then starting from Wednesday, we'll learn about loops. So things will just get more sophisticated. So just get ready for that, right? We are almost halfway through of the course, almost. Okay, that's logical law over here, and then I would like to talk about something, something we just covered. Okay, about the precedence, it's very easy. This is what you can think about. Think of conjunction like multiplication, and think of disjunction like addition. So what does that mean? That means the following. I'll show you one example right away. Okay? You have to know very well when you don't have parentheses, what should be the order of evaluation. That's the key thing to notice. Good. So now let's have a look. I want you to first of all look at this particular expression. We got P or Q and R. So we got a mix of disjunction and conjunction. We got this, right? There's no parentheses. Okay? So now we want to know exactly what it really means without the parentheses. Okay? So now it can potentially mean something like over here, which means we try to bracket to say we do the conjunction first, number one. Or it can be number two, where we try to do the disjunction first, right? But which one does it really mean? Which one? It should be the left-hand side, simply because, remember what I said before? You can think about conjunction is a little bit more like a multiplication. And disjunction over here is a little bit like addition. If you got 3 plus 3 times 4, you know pretty well implicitly, you simply got a brackets over here, right? You got to do multiplication first. Okay, the same idea. So now let's do a very quick analysis here. So now we want to show you that you have to know pretty well exactly what order you should really evaluate the conjunction and disjunction for this particular example, because either you bracket this way or you bracket this way, they're going to give you different result. Let's see how it's going to happen. Okay? So now let's try this. Let's try true, true, and false. Okay? So P is true, Q is true, and R is false. Right? Here we got true, true, and false. What should be the value for the left-hand side over here? Well, to be honest, you don't even have to bother worrying about this particular part, because the left-hand side is already true for disjunction, right? So now it would just be true for the left-hand side. What about the right-hand side over here? For the right-hand side, again, it's a no-brainer, because you don't have to worry about this part really, because one of the side is already false for conjunction, right? So it will just be false. You can see, depending on how you bracket the expression over here, either doing conjunction first or disjunction first, in general, they are not equivalents. So So that is why you have to know pretty well. When I give you something like this without the brackets, what it really means. Okay, that's the idea. But the best way to remember it is conjunction is like a multiplication, disjunction is like a addition. Okay, that's the best way to remember it. Okay, so that's just about precedence, very easy. So we just have gone through that. And then we can learn about associativity, that's even easier. So for example, if you got, for example, 1 plus 2, let me just give you this. If you simply got false or true or false, associativity simply means when you have no brackets over here and all the operators are the same, we are only using disjunction over here. It's simply just going to evaluate from left to right. Okay, you will do the left-hand side disjunction first, get the result, and then you do the right-hand side disjunction second. Okay, this associativity is not as tricky as the precedence. So now let's talk about something very interesting over here. Okay, it's something called short circuit evaluation. Okay, let me show you some Java code on Eclipse first, and then we want to figure out from the errors that we are having. Okay, so that's something I want to show you. Now I want you to, I'm going to make this source code available to you after class today. Let's try to read the source code very quickly together. Basically, we have a scanner for user input over here, and also we simply prompt the user for 2 integers. We prompt the user for x, and then we prompt the user for y, 2 integers. Okay, and then we have an if-else condition over there for us. So now for the if condition over here, look at what I'm trying to do here. I say if, to help you understand, if you can just look at the right-hand side of the conjunction first, we're trying to do y divided by x is larger than 2. So now, as you learned back in high school, every time I want to do division, there's one value for the denominator I need to be careful about, which means I don't want to have division by 0. Agree? If I got division by 0, the result is simply undefined. In the case of Java, if you try to do, for example, 10 divided by 0, it's going to crash. Okay? So now, it seems like we try to do the following. We say that since we are trying to do y divided by x, so I want to make sure x should not be 0. That's why I'm putting a conjunction over here. Okay? I'm saying if the denominator x is not equal to 0, and also the result for the division over here is strictly larger than 2. If this is the case, I'm going to print out some message over here to say y divided by x is greater than 2, right? Easy over here. Otherwise, now if you can try to apply the law that we just talked about, right? If I can reach the else branch, so what does that mean? That means it is not the case that this particular conjunction is actually true, right? In that case, what will be the law be simplified into? So that means I simply got, it is not the case that x is not equal to 0, or it is not the case that y divided by x is larger than 2, right? I'm just simplifying up to here. You can do the rest. Okay, again, there's really a reason I want you to learn the logical law for conjunction and disjunction. It just make the analysis of your program much easier. So now, in that case, we try to say if x is really 0, then I would say error, division by 0. Otherwise, I will simply tell you if x is not equal to 0 and we still do the division, and we'll just tell you the division result is not greater than 2. Okay? Very simple program. You can look at the specifics of the program a little bit later. What I want you to focus on will be line number 14. Okay? Line number 14 over there, I got a conjunction over there, the left-hand side and the right-hand side. And the left-hand side over there seems to be having the following purpose. We want to make sure if you want to do division, the denominator should not be equal to 0. Right? So now, let's try to run the program quickly and then let's see. Just make sure it works. If I simply run it over here, okay, so now I see x. For example, x is simply 0, which means I want to do division by 0, but it should be caught, right? If I can, thank you. Let me just try to make this a little bit, if I can, okay, console. Let me just put it on the button over here. Okay, that'll be better. If I say enter x, 0, and then what about y? Let's say I want to do 10 divided by y, 10 divided by 0. In that case, it will tell me error division by 0. Agree? Okay? That simply means it's simply just going to go to this particular branch and tell me that, it's going to go to this particular one and telling me that it's division by 0. On the other hand, let me try another input for you. If I try over here, let's say x is maybe 2 and then y is 10. In that case, it will tell me that y divided by x is greater than 2, right? We got different cases over here. Okay. Now, watch what I'm going to do over here, right? This is exactly the topic for short circuit. Now, let me just ask you one thing over here. Very important intuition for you to have. Usually, if I say P and Q versus Q and P, these two expressions, intuitively, you would think they mean the same thing, right? I'm either saying P and then Q, or I say Q and then P. Logically speaking, they are the same. However, Java is a programming language. The way they treat this conjunction and similarly disjunction there is different. That's why we're going to talk about it. Okay? So now, let me just show you the following. Let's go back to the Java code over here. The only place I'm going to modify is as follows. What I would do is, let me just maximize the code over here. So let me just comment out line number 14, right? Basically, what I would do is, I'm going to swap the order of the two conditions. I would say if y divided by x larger than 2 and x larger than not equal to 0. That's all I did. So now I want you to compare very quickly. In line number 14, I simply say P and Q, right? In line number 15, I actually swap the order, so it's Q and P. We would think they should be equivalent, right? So now, let's try specifically the value for x being 0. Previously, it will simply tell me the error, division by 0. But let's see if the program might crash or not. I can tell you that it's going to crash. Okay? Just by swapping the order of the operands. That's why we need to talk about a short circuit. So now, if I simply try to execute a program over here, okay, again, let me just try to put it on the bottom here. Okay? Now, if I say 0 over here, and then I got 10. Previously, before I swapped the order of the two operands, I simply got the program terminated properly, say error, division by 0. As soon as I say enter, oops, the program crashed. Okay? Crashed, saying we got division by 0. It's a different, right? It's different behavior. In the first version, when we say P and Q, it gives us normal persistent out of print line. In the second version, when we say Q and P swapped, it tells us crash. So why is this happening over here, right? So that's why we want to learn about a very important detail about conjunction and disjunction in Java, and also in C# or other OOP language. It's something called short circuit. Let me try to explain to you the idea over here. Short circuit evaluation. Okay? So now this is how you can think of it. Let me just summarize exactly what it means, and then we'll revisit the example together. Okay, so now, when you have P and, okay, it's still visible. When I have P and Q, we know that the only way to make it true is P is true and Q is true. Okay, now at the runtime, the only principle you have to remember is how are we going to evaluate this particular conjunction? Runtime number 1 evaluates P from left to right. And then I would say if necessary, so here if necessary is important, evaluate Q. Okay, at the runtime, this is what's going to happen. Again, it's from left to right. Do P first, and then evaluate Q if necessary. So what does that really mean when I say if necessary? As follows. Now, at the runtime, imagine this. If I try to evaluate P always first, if I know already P is false, do I have to bother evaluating Q really in order to know the result for conjunction? I don't have to, because if already one of the operands is already false, if it is already false, that means do not need to evaluate Q. Okay? That's the so-called short circuit. which means at the runtime, when Java try to evaluate P first, if it noticed that P is already false, that means conjunction was destined to be false anyway, so Q would just be ignored. And the overall result just be false. On the other hand, if I try to evaluate P at the runtime, it tells me that it is true. So now, do I have to evaluate the right-hand side? I have to, because it now really depends on what Q is. If Q happens to be true, overall it will be true. If Q is false, overall it will be false, right? It's really important to see this. So now, what I want to do is, let's think about what we did previously over here. Okay, I'm going to write it down over here. What we did in the Eclipse example over there was like this. So we say, I'll put it down. We say if x not equal to 0 and also y divided by x larger than 2, right? That's what we have. Okay, just this branching condition over here. This is version 1. In version 2, we simply swap the order. We say if y divided by x larger than 2 and x not equal to 0, right? That's the only difference is we swap the condition order. So now, let's try again, okay? So now, we know that version 2 crashed when x is equal to 0. However, version 1 did not crash. Let's see why. So now, let's say x is simply equal to 0. Let's say the user enters x being 0. Let's see version 1. How is that going to be evaluated? Left to right. When we evaluate the left-hand side over here, so x is simply 0. 0 not equal to 0 is going to give you false. So that means it's already false for the left-hand side. Because of the short circuit effects, we don't have to bother to evaluate this. Okay? So now this will not be evaluated for conjunction. Because we know that overall conjunction will just be false anyway. Okay? That's for version number 1. For version number 1, it didn't crash simply because the x not equal to 0 is put it on the left. So it's evaluated first, and it's going to be false first. So we don't have to bother. What about the version number 2? Version number 2, hopefully you can now see it, but let's do it anyway. For version number 2, we are, again, left to right. We're just going to evaluate this left-hand side no matter what. In that case, when x is equal to 0, we got 0 over here, and y was 10. And now we're going to evaluate this first, even before we try to check this. So it was too late when we check it, right? So this one here is just going to crash. Okay, that's the so-called short circuit. Okay, let me just mention one more thing. Okay, we got maybe 1 or 2 minutes. Okay, just one more thing. So now the short circuit for disjunction is analyzed in a similar way. If I got P or Q at the runtime, again we're going to evaluate P first, no matter what. So we're going to evaluate P, and then, if necessary, we're going to evaluate Q. But what do I really mean by if necessary? So let's see that part, and then we're done. Okay, just give me 1 more minute. Okay, so now, if I know that when I try to evaluate P first, if the result is already true, as opposed to in the case of conjunction, I know the result is already false, right? It's symmetric. If I know that P is already true, what would be the result for disjunction anyway? It will just be true. It doesn't really matter what Q is. Doesn't really matter. Okay, so now if P is already true, and Q will not be evaluated. It will simply not be evaluated. On the other hand, at the runtime, if P happens to be false, in that case, we still have to bother to evaluate Q, because if Q happens to be true, overall it will be true. If Q happens to be false, overall it will be false. So it really depends. Okay, I will review this short circuit in the beginning on Wednesday. I'll see you there.